Assalamu alaikum guys, welcome back to a continuation of 7.6. Inshallah, we're going to cover a little bit more of what I had not covered on Friday. I just didn't want to overload you all. So the instructions are to factor completely. So in factoring completely, you're usually looking for a GCF so you can simplify the trinomial. So here we go. GCF in this case, all of my terms are divisible by 3. And if they're divisible by 3, that means I can pull a 3 out. So by pulling a 3 out, 18x squared divided by 3 is 6x squared. And then negative 33 divided by 3 is negative 11x. And then 12 divided by 3 is plus 4. Now we're going to go back to what we were doing in the previous lesson. We have 6 and 4, so 6 times 4 is equal to 24. And remember your two conditions. Whatever the product of two numbers is has to equal the 24. At the same time, the sum has to equal negative 11. And negative 11, sorry that you couldn't see that. Negative 11, remember, is your middle term. So now for the next step is, what are the factors of 24 that give you that negative 11 and 24? So I know that 3 and 8 are the only numbers that I can use. Since it's negative 11, both of the numbers are negative, okay? So let's go ahead. Keep track of this 3. This 3 is on the outside. 6x squared drops down, and it's minus 3 minus 8. So minus 3x minus 8x plus 4. And then we're going to go ahead and cut it in half. And what's the GCF in each half? This first half, the GCF is 3x. The second half, remember, it starts with a negative. And it's going to be a negative 4 because 4 is divisible into 8x and 4. So here we go. How do you keep track, especially when you start having a lot of numbers sitting on the outside and the problem gets expanded? You do a bracket. This is kind of like a square type thing. So here we go. 3x was factored out, and then we go 6x squared divided by 3x is going to give you 2x. And then negative 3x divided by 3x is negative 1. Now, my GCF over here was a negative 4, so we write minus 4. Then go ahead, negative 8 divided by negative 4 is positive, and then 8x divided by 4 is equal to 2x. And then positive 4 divided by negative 4 is negative 1. And remember, before I decide on my final answer, are my parentheses the same? They are. So my GCF that I factored out from the very beginning gets written down. One of my factors is 3x minus 4, and the other factor is 2x minus 1. So this is what factoring completely means, guys. So on your worksheet, I kind of indicated I'm going to help you out what parts you need to be factoring out before you do anything, or start factoring out, because this part of the lesson also continues into, Chapter 7.7. So I kind of have to introduce it, but it was done in chapter, 7.6. Now, our next example, and it's not always a number, sometimes it's a number with a variable as well. Let's say that we have 3x cubed and minus 21x squared, and then minus 54x. So all of these I know are divisible by an x because that one right there has an x. And then I also know that all of them are divisible by 3. So the GCF that I'm going to pull out is 3x. And actually, this one is 3x. So 3x, and then parentheses open. What is 3x divided by 3x cubed divided by 3x is going to give you x squared. Then negative divided by a positive is negative. 21x squared divided by 3x is going to give you 7x, negative 7x, right? And then the next step is negative 54x divided by 3x is negative 18. All right, so notice that this one doesn't have a leading coefficient now, so this is going to be the easier one, which was less than 7.5, right? So what times what gives us that negative 18? At the same time, when we add it, it gives us negative 7. So the factors of negative 18 that give us a sum of negative 9, it's 2 and 9, right? So 2 and 9. And remember, it's a negative 7, so therefore the 9 has to be negative. Okay? So this 3x is on the outside. Here we drop x squared, and then it's plus 2 minus 7, so plus 2x, sorry, minus 9, minus 9x, minus 18 drops down. Divided in half. GCF on this half is x. GCF on this half, it starts with a negative, so it's negative 9. This 3x drops down. And don't forget your bracket. GCF on the first half was x, and then x squared divided by x leaves you with x. Positive 2x divided by x leaves you with a plus 2. The next step, your GCF over here was negative 9, so minus 9. And then go ahead, 9x divided by 9, because you remember negative divided by negative gives you a positive. 9x divided by 9 leaves you with x. And then negative divided by negative is positive. 18 divided by 9 is 2. And before we can finish, checking mechanism, both parentheses are the same. So my final answer, don't forget the 3x that was outside, the other one x minus 9. And then the last one is what's in parentheses. So that is what factoring completely means, okay? So now that's the last of 7.6. Let's twist this way, and let's focus, because I know that the light gets in the way, but let's focus this way. Sorry, guys. Let's focus this way. And now we're doing difference of, what do you call it, 2 square patterns. So in the past, we were dealing with, remember when we were saying the sum difference equal to a squared minus b squared? Now we're going the other way around, where a squared minus b squared is equal to the sum difference, okay? But it's called difference of 2 squares patterns. So here we go. Now, how do you show workout for this? So you're being asked to factor. So the way to show workout for this is you're going to check, first of all, if these are perfect squares or not, okay? So y squared is a perfect square, and it's y. 9, this is the square root of 9, is a perfect square, and it's 3. Since both of these terms, both of these were perfect squares, then I can say that y plus 3 was one of my factors, and y minus 3 was another one of my factors, okay? So let's try another example. Let's say that we have 64c squared minus 16, okay? So let's go. Is 64c squared a perfect square? 64 is a perfect square at 8. C squared is a perfect square at c, so this is 8c. And what about 16? 16 obviously is a perfect square at 4. Since both of these terms were perfect squares, then I can say that 8c plus 4 and 8c minus 4 were the 2 factors that produce that product, okay? So let's do one more actually I have to do like 3 more examples on this, because this is where factoring out completely also comes to play. So let's say, for example, x squared minus 81y squared. All right, is x squared a perfect square? Yes. Is 81y squared a perfect square? Yes. And that equals to 9y, right? So if they're perfect squares, this x and this 9y, that becomes your sum difference, x plus 9y and x minus 9y, okay? And that's our answer right there on the top. Now, they're not always perfect like that, guys. You're gonna have to force it to become perfect. What if we have 12 minus 48 and let's say m squared? I know that 12 and 48 are not perfect squares, but can I force it to become a perfect square? Absolutely. If I divide by 3, I pull out a GCF and rewrite the equation or the expression. 12 divided by 3 is 4. I know that 4 is a perfect square. 48 divided by 3 is 16. I know 16 is a perfect square as well. So here we go. Remember, test 4 is a perfect square. 16m squared is a perfect square, right? Don't forget that we factored out the 3. So my final answer here is that 3 that we factored out, and then my 2 terms, 2 plus 4m, and then the other one is 2 minus 4m. So my complete answer is right there, okay? Best way to write it, obviously, guys, I have a very small board, but 3 is the factor. 3, and then it's 2 plus 4m, and then 2 minus 4m. Don't forget your parentheses as well. So that's the best way to write it. All right, let's try one more where we have to force it to become a perfect square. And watch this one. So our next example, it's negative 3n squared plus 75, okay? And one of the things that you have to remember, guys, is that it's always been a negative on the middle term. Right here, we have a positive in the middle term, so, and besides the 3 and the 75 are not perfect squares. But since it started with a negative, I'm going to factor out a negative 3. So negative 3, and then I rewrite my equation, n squared, positive divided by negative is negative, and then 25. Now, if I have a negative right here, remember that's where it applies the sum difference. Test, is n squared a perfect square? Yes. Is 25 a perfect square? Yes. So then my final answer is what? Don't forget the negative 3 that we factored out. So it's negative 3, and then n plus 5, and n minus 5. Now, one thing to point out, just remember, the sum difference is always when you have a negative. If this would have been a plus 25, there's no way that this, would have worked, okay? So now let's go to the last of the lesson. The last of the lesson is the other pattern that we were doing. Remember the a squared plus 2ab plus b squared? So this is called the perfect square trinomial pattern. Now, the perfect square trinomial pattern basically means a squared plus 2ab plus b squared will equal to what? A plus b squared. And at the same time, remember the a squared minus 2ab plus b squared, since it's minus, it's going to be a minus b squared. Okay? So we're working backwards now. So let's go for our first example. Let's say that they give us p squared minus 12p, okay, plus 36. Now, yes, you can factor this with doing the 2 conditions, but the 2 conditions you're going to notice in a little bit the way I do it on this type of pattern, it's going to be shorter than what 2 conditions are the product of such and such and the sum of such and such. So here we go. When you're looking for a perfect square trinomial pattern, the first thing you're going to test is if the leading term and the last term, which is a constant, if they're perfect squares. So remember, is p squared a perfect square? Yes, it is. Is the 36 a perfect square? Yes, it is. Now remember that this is minus, right? So that means we're dealing with this one right here. So I am going to take that minus 2. Okay, the minus 2, remember, is that term right there. And I'm going to multiply it to p, which is my perfect square of p squared. And I'm going to multiply it also to the 6, which is the perfect square of 36. Now, when I get this product, when I multiply it, it should give me the middle term. If it gives me the middle term, then I know that I can use the a minus b squared. So negative 2 times p is negative 2p times another 6. It equals to negative 12p. And notice, negative 12p, negative 12p. So that means that my pattern is the a minus b squared. And my a was p, my b was 6. So p minus 6 squared, that is my answer. Yes, these take a little bit of practice, guys. but I'm more than sure that you can do it. Just watch the video maybe more than once, okay? Or slow it down and just repeat, rewind, and what have you. So let's go to the next one. Let's say that we have 4n squared plus 20n, and then plus 25. Remember, it's the plus, so we're dealing with the first one, the plus 2, okay? So first of all, figure out, is 4n squared a perfect square? Yes, it's 2n. Is 25, which is the last term, is it a perfect square? Yes, it is. Since this is positive, I'm going to take the 2, the positive 2. I'm going to multiply it to 2n, and I'm going to multiply it to the 5. If the product of this gives me the middle term, then I can use that pattern. So 2 times 2 times 5 is 20 times n, 20n. I got 20n, 20n, both are positive. So therefore, I know that I can use a plus b squared. So right here, remember my a was 2n, my b was 5. So I can say 2n plus 5 squared, and that's my answer. Okay? Now let's do one where you have to factor out a value because it's not a perfect square, but you're going to force it to become a perfect square. And I promise this is the last example that we'll do. So let's say that I have negative 2x squared minus 16x minus 32. So regardless whether I can factor something or not, I know I have to factor at least a negative, right? I also know that all of these, guess what? They're divisible by 2. So I'm going to divide everything by negative 2. So negative 2, and then I rewrite. Negative 2x squared divided by negative 2 leaves me with x squared. Negative divided by negative is positive. 16x divided by 2 is 8x. And then negative divided by negative is positive. 32 divided by 2 is 16. Now the next thing I do, I have to test my x squared and my 16. Obviously x squared is a perfect square, and 16 is a perfect square at 4. Since it has a plus sign right here, then that means I'm doing this one right here. So I'm going to take positive 2 times x times 4. If I multiply all of this, it gives me 8x, right? 8x is my middle term. So I know that I'm going to be using x plus 4, which is a plus b squared. But don't forget that you have that negative 2 that you factored out. So my final answer is negative 2, and then in parentheses my a and b was x plus 4, and it's going to be squared. All right? So inshallah you found this. Maybe, I know it's a little bit difficult, guys. You're working backwards and you're working forwards. It's a lot of information, but inshallah I have confidence in you all. If you watch the video and slow it down and rewind a little bit, I have confidence that you'll master this, inshallah. More than anything, what I want is for you to have these notes, especially for this year and the following year after that. Don't throw your notes away, please. You know, you're going to need them, and, you know, factoring, not every teacher knows how to teach it. So I'm hoping that you're getting the benefit out of this lecture, inshallah. If you have any questions, don't hesitate to come to class so that I can help you with anything that you need. Assalamu alaikum, guys.